All right, so we want to review solving equations and inequalities because as you've seen throughout Algebra 2, you're going to be doing a lot of solving equations and inequalities, but mostly equations. So we want to review some of those steps. So with this first example, we have 3n minus 5 equals negative 8 times 6 plus 5n. We want to simplify this. Essentially, we want to end up with 1n equals some number. Okay, that's what we're hoping for. So let's look at it. I'm going to draw a line, okay, right down the middle to separate our left side from our right side. You always draw your line at your equal sign because your equal sign is what separates the left from the right, okay? So on this left side, I have 3n minus 5. These are not like terms. I cannot subtract these. I cannot put these together. This one has an n, this one does not, right? Then on the right side, I have a negative 8 times. I'm saying times because when you have a number and nothing in between that number and then parentheses, that means they're being multiplied, okay? This negative 8 is not just being multiplied by these 6. These parentheses say that negative 8 is being multiplied by everything inside of the parentheses, right? So I can actually do something with that. Inside of parentheses, I can't add 6 and 5n together because they're not like terms. This one has an n, this one does not, right? You can't add and subtract unlike terms. But what we can do is we can take this negative 8 that's being multiplied by my parentheses and we can distribute it or multiply it to everything inside of the parentheses. So a negative 8 times 6 would be a negative 48, and then negative 8 times 5n would be a negative 40n, okay? And then on this left side, we weren't able to simplify, so we're just gonna bring it down. Now, once again on the left side, still can't do anything. On the right side, these aren't like terms. I still can't simplify these, but what I can do is I can now work on getting my n's to be on the same side and then the terms without n's to be on the same side. Now, it doesn't matter whether you choose to move n's to the right side or the left side, okay? It does not matter. You get this same answer either way. So let's say I wanted to move all my n's over here to the left side. Well, that would mean I would need to move this n over. I would need to cancel it out from the right side. So to cancel out a negative or a minus 40n, we would do the opposite and we would add 40n, because a negative 40 plus 40 is 0. And whatever I do the right side, I have to do to the left side. So a 3n plus 40n gives me a 43n minus 5 equals a negative 48. Okay. Now that I moved in to the left side, everything without an n now needs to be on the right side. Okay, I want n's on one side and everything without an n on the other side. Okay, so to cancel out a minus 5, I'm going to do plus 5. Negative 5 plus 5 is 0, so I'm just left with 43n equals a negative 48 plus 5 is a negative 43. Okay, so divide both sides by 43. And we get n equals negative 1. Can I check that answer? Absolutely. So what this means when I say n equals negative 1, that is the value that I would need to plug in for both of these n's in order for this left side to be the same as this right side. Okay, so let's try it. I have 3, and then in parentheses I'm putting my n, which is negative 1, minus 5 equals a negative 8 times 6 plus 5 times negative 1. Okay, I put the double parentheses right here because this negative 1 has parentheses, and then these are the parentheses for that whole section. Okay, so 3 times negative 1 is a negative 3 minus 5 equals a negative 8 times 6. 5 times a negative 1 makes a negative 5. Okay? Now we can simplify. Negative 3 minus 5 would be a negative 8. to simplify, first I want to do inside of parentheses 6 minus 5 is 1. And negative 8 times 1 is a negative 8. So we get negative 8 equals negative. So you can see that by plugging in negative 1 for both ends, like we did here, it made the left side equal to the right side. Okay, so n equals negative 1 is our answer. All right, number 2, we have 24a minus 22 equals a negative 4 times 1 minus 6a. Okay, so for this example, we need to start just like we did the last one by saying what we can simplify on each side. So on the left side, I have 24a minus 22. These are not like terms. I cannot simplify anything there. On the right side, I have a negative 4 times 1 minus 6a. That I can simplify. So I can go ahead and distribute this whole thing, the whole negative 4, to everything that it's multiplied by inside of the parentheses. I'm going to bring down 24a minus 22. If you want that line, go ahead. Negative 4 times 1 is a negative 4. Negative 4 times a negative 6a. Negative and a negative make that a positive 24a. Okay? If you're already noticing something, that's awesome. If not, that's fine too. But if you're already noticing that our terms with variables, we have a 24a and a 24a. They're the same, right? So already that should kind of send up a flag that something else is going on here, okay? If not, it's fine. You'll see it in 1 second. So notice, just take note that the variables are the same and then our terms without variables are different, okay? So let's look. If I were to get my variables on the same side, once again, doesn't matter which side we choose to move them to. So if I just subtracted 24a away on this side, 24a minus 24a would be 0. And whatever I do to the right side, I have to do to the left side. Once again, 24a minus 24a is 0. So then I'm left with negative 20. Sorry, negative 22 equals negative 4. All my variables went away. So am I going to end up with a equals to something? No. I end up with negative 22 equals negative 4. Is that true? Is negative 22 actually equal to negative 4? Absolutely not. This is not true. So when we have something like this, we say that our answer is no solution because there is no value that I can plug in for a in order to make these two sides equal each other because I don't even end up with an a, right? So no solution. So when you start seeing that you have the same variable term on each side, but the values without variables, those terms without variables, are different, then it's no solution. Okay, so we have 2 times 3x plus 5 equals 3 times 2x plus 3 plus 1. Okay, so we're going to start by, I'll draw my line, where you want to simplify each side. So I have a 2 being multiplied by 3x plus 5, so I want to simplify that. 2 times 3x is a 6x, and 2 times 5 is a positive 10. On the right side, I have a 3 times 2x, which is 6x, and 3 times 3, which is 9. It's not being multiplied by my 1 because my 1 is being added outside of the parentheses. So I'm just bringing down my plus 1. Can't combine anything on this left side. A 6x and a 10 are not like terms. So one has an x and one doesn't. And then on the right side, I have a 9 and a 1. Those are like terms because neither have variables. So 6x plus 9 plus 1 equals 10. And I can stop there. 6x plus 10 on both sides. So I'm done. I already see that both sides are exactly the same, which means it doesn't matter what number I plug in for x. If I plug it in on this side and I plug it on this side, It's gonna give me the same answer on both sides, okay? If you wanted to keep solving, you would subtract 6x from both sides to move it from one side to the other, but they end up canceling out on both sides and you get 10 equals 10. 10 equals 10 is true, just like 6x plus 10 equals 6x plus 10. So you're done, okay? Your answer is all real solutions. Okay?